Hello, my Trig students. This is going to be section 7.4. It has 20 questions, so I'm splitting it into a part A and a part B. So this is section 7.4, part A. These are the notes and me doing practice problems. Now, in this section, we are solving trigonometric equations for all possible values, okay? And most of these are in radians. You'll know if they ask for degrees, but most of these are in radians, so make sure on your calculators that you have it in radian mode. Now, my number one says solve the given equation. And here's my equation. Cosine theta equals root 2 over 2. Now, by the question, it says, enter your answers as a comma-separated list. Let k be any integer. Round terms to 2 decimal places where appropriate. Now, if we don't get some nice, neat answer like we would on our unit circle, then we're going to have to poke it in our calculator and get some decimal approximation for radians. Most of these will be normal that we can pull off our unit circles. So you might want to have your unit circle handy. But now we are solving for the theta. But again, we have to allow for every possibility of theta. So a couple of things jump out at me here with cosine. First of all, we are trying to find the value of theta. That's our degree or radian measure, okay? That yields a root 2 over 2. So first of all, cosine, where is cosine positive? Cosine is positive in quadrant 1 and quadrant 4. I'm just going to put Q1 and Q4. That's quadrant 1 and quadrant 4. Remember, cosine is your x-axis. So you are going to get positive results for cosine in quadrant 1 and 4. So what we're actually asking is the arc cosine of root 2 over 2. And if you look on your unit circle, we've already gone over these. I don't know if you remember them, but those are the ones that have the root 2 over 2 are all your like 45-degree ones. But again, we want this in radians, okay? Unless they tell you specifically to do degrees, we need them in radians. So in quadrant 1, okay, this is pi over 4. It is also 7 pi over 4 in quadrant 2. So again, you have to account for each possibility. Now, we're also not done. Okay, that's just kind of the first part. So pi over 4 is quadrant 1. Again, if I draw my unit circle here, okay, this is pi over 4. This down here is negative pi over 4 or 7 pi over 4. Okay, so first and fourth quadrant give us positive cosine. Now, we have to account for every possibility. If you remember, part of the direction said let k be any integer. Well, what they're getting at is that this is cyclical. Okay, if we are going around our unit circle, it's going to be pi over 4. It's going to be 7 pi over 4. It's going to be 9 pi over 4. It's going to be, what would the next one be? 15 pi over 4, and so on. It's cyclical. It keeps going around and around and around. Now, that means that each one of these, this becomes pi over 4 plus 2 pi. This becomes 7 pi over 4 plus 2 pi, but not just 2 pi, it just keeps going. We can do it for 4 pi and 6 pi and 8 pi. And so we use a constant k. That's where this constant k comes in. Okay, constant k is just to tell us how many times we go around the circle. Okay, k can be 0, k can be 1, 2, 3, 4. So what this does is it gives us two different answers. This is actually one of our answers. This is the other answer. So we have pi over 4 plus 2 pi k, or 2k pi. I don't think it really matters what order you write it in. And then 7 pi over 4 plus 2 pi k, or 2k pi. Those are your two answers, and that's literally how you have to list them, with a comma between them. Okay, so in your box, I would list pi over 4 plus 2 pi k, comma, 7 pi over 4 plus 2 pi k. That's your answer in your box in WebAssign. Oop, I kind of cut over my 7, didn't I? Okay. So that's your answer on that one. Hope that makes sense. So again, the k is a constant that just represents how many times around the circle you're going to go. Remember, each circle iteration is 2 pi. So once around the circle is 2 pi, second time is 4 pi, third time is 6 pi, and so on. Okay, so that's what k represents. All the possibilities. Well, you could keep doing this forever. Okay, so that was my number one. So a couple of things I want to point out. You have to make sure you're in the right quadrants. Okay, you have to make sure you get both possible answers. There's usually two. Okay, and then you have to add the plus 2k pi for cosine and sine. Tangent, if you remember, the period of tangent is just 1 pi. So it would just be 1 pi k instead of 2 pi k for tangent. Okay, let's keep going. Next problem, my number 2. Again, solve the equation. Enter your answers as a comma-separated list. Let k be any integer. Round terms to 2 decimal places where appropriate. So my problem is sine theta equals negative 0.15. So again, the first thing that jumps out at me is what quadrants is sine negative? Well, sine is negative, okay, in sine is negative in quadrant 3 and quadrant 4. If you remember, sine is your y-axis. So sine is positive first and second, negative third and fourth quadrants. So now, 0.15, not on our unit circle. We're actually going to have to use our calculator and do arc sine. Okay, so my theta is going to equal arc sine of negative 0.15. Make sure your calculator is in radian mode. Okay, so when I poke this in radian mode, I literally get negative 0.15. Okay, get the same answer back, believe it or not. Now, again, picture this as our unit circle. This would be a negative 0.15 radian, and then I'm also going to have one here that's going to be pi plus 0.15. Okay, now this negative 0.15, okay, is there in the fourth quadrant. That is actually 2 pi minus 0.15. Okay, does that make sense? So again, third quadrant, we actually get pi plus 1.5 because again, remember, pi is 180. From here to here is pi. Okay, and then we want our relative angles. Here's our relative angles that we need. And so pi plus 0.15, and then the negative 0.15 is in our fourth quadrant, but this is actually 2 pi if we're going all the way around. Okay, let me use a different color here. If we're going all the way around, then click, I guess, then this is 2 pi minus 0.15. Because again, 2 pi is all the way around. So that being said, okay, pi plus 0.15, literally, okay, if you poke that in the calculator, I would use the pi button so there's no rounding issues, but actually 3.14, since we rounded to 2 places, would work on this one. We get 3.29. Okay, now 3.29 again is one of the 2 answers, but it is going to cycle every 2 pi. Okay, it's going to cycle around. So again, we have to add 2 pi k to that. That's one of our answers. Okay, then we're going to put a comma between them. Our other answer is 2 pi minus 0.15. Again, you poke that in a calculator, you get 6.13. But again, that cycles every time you go around the circle. It occurs in that same place. So how do you get from one of those to the next? You add 2 pi to it. So this is 2 pi k, depending on how many times you go around the circle. That's what the constant k stands for. So let me just write constant k represents how many times you go around the circle to end at same value. Okay, so let me say that. Constant k represents how many times you go around the circle to end at the same value. That's what our k is. So again, on your answer and your block, you would put both answers separated by a comma. Okay, so again, you need to look at your answer, figure out what quadrants it's in. If you need to draw a little picture, I'm a visual person, you need to figure out how to orient that around your unit circle. And then if it's sine or cosine, you need to add 2 pi k to it each time. If it's tangent, you're just going to add pi k, because the period of tangent is just 1 pi, not 2. Okay, number 3, moving along. Again, solve the given equation. So now I have cosine theta equals 0.04. Now, once again, this is positive. So I know that cosine is positive in quadrant 1 and quadrant 4. Okay, so now to solve for theta, theta is going to be the arc cosine of 0.04. And again, if I poke that in my calculator, I get 1.53. And it said to round to 2 decimal places where appropriate on mine. So this equals 1.53. Now again, in my unit circle, okay, 1.53, I don't know, up here somewhere, okay. Now, that's quadrant 1. How do I get that all the way around to quadrant 4? I need this one to also be 1.53. Well, this is going to be 2 pi minus 1.53, right? Because I'm subtracting 1.53 from 2 pi. So those are, again, my 2 choices. So 2 answers. First one is 1.53. This is quadrant 1. Okay. 1.53 plus 2 pi k. It's going to occur every time you go around the circle in that same spot. Okay. And then my answer for quadrant 4 is going to be, if I take 2 pi minus 1.53, I get 4.75, and again, plus 2 pi k. That accounts for every possible answer, because again, it's cyclical. It happens every time you go around the circle in that same spot. So that's what the constant K represents. Okay, those are my two choices, one in the first quadrant, one in the fourth quadrant. Okay, next problem. Number 4. Now, this one, same type of deal, solve the given equation, but now I have tangent theta equals 9. Now, if you remember, tangent has a period of only 1 pi. Tangent has a period of only 1 pi, not 2 pi, like sine and cosine. Okay? So if you kind of remember the graph of tangent, I'll kind of quickly put it up here. If you remember, it goes from pi over 2 to negative pi over 2, and there's actually asymptotes at those, you remember? So the graph of the tangent function looks like this, okay? And then the next one's going to be, where it's 0 is going to be at pi. And again then, if this is 3 pi over 2, we're going to have another asymptote. And then my tangent function looks like that. So if you remember, tangent only has a period of pi. Okay, so now going back then, also tangent is positive in what quadrants? Okay, tangent is positive in the first quadrant. And so since this is going to be cyclical every pi, then it's going to happen in first quadrant, third quadrant, first quadrant, third quadrant. But I don't have to find both answers. I can just find the one and then add pi k to it. That'll give me the next one in the third quadrant. Then add another pi to it. It goes back to the answer in the first quadrant and so on. So theta equals the arctan of 9, which again, if you poke that in a calculator, is 1.46. Now again, we're looking for something cyclical. We're looking for every occurrence. Okay, so it's going to happen in the first and third quadrants. First and third quadrants, tangent is positive. But since tangent, again, just has a period of 1 pi instead of 2, then my answer would be 1.46 plus pi k. Okay, I don't have to list both of them and then do 2 pi k. I just have to list them one, and then instead of having a 2 pi period, it's got a 1 pi period. Okay, so it just has one answer. Okay, now, problem 5. Solve the given equation. Again, enter your answers as a comma-separated list, let k be any integer, but then there's 2 parts to this. Once we give the generic 2 possible answers, then we have to list 6 specific solutions. So we got to take it a step further. So my problem is cosine theta equals 1/2. Well, again, cosine is positive in quadrant 1 and quadrant 4. Cosine's positive, quadrant 1 and quadrant 4. Now, again, if you also look on your unit circle, if I'm trying to find my theta is arc cosine of 1/2, and those of you that have the nice Casio calculators, it'll spit it out at you anyway. But cosine of 1/2 is pi over 3. Okay, So if you poke that in a calculator, you're just going to get pi over 3. However, again, if we're looking at my unit circle, okay, here's my pi over 3. But again, if this is also like a negative pi over 3, which would actually be a, well, 2 pi minus pi over 3, which is the same thing as, again, if you go all the way around your circle, 2 pi over 3, sorry, 2 pi minus pi over 3 is 5 pi over 3. Okay, so we actually have two answers. We have this answer that we need to add 2 pi k2, and we have this answer that we need to add 2 pi k2. So these are the two answers for the first blank. Okay, because again, it occurs in the first quadrant and in the fourth quadrant. So again, in your blank, you would have pi over 3 plus 2 pi k, comma, 5 pi over 3 plus 2 pi k. That would be your answer block. Okay, now that's the first one. Okay, the second one says list 6 specific solutions. So we are literally going to take each one of these, and I don't think they have to be listed in order, but we're going to take each one of these and add a 2 pi to it to keep going. Now, let me do a little aside here. 2 pi is the same thing as 6 pi over 3. Okay, so what we're actually doing here on this one, let me do a different color. We are taking pi over 3, then we're taking pi over 3 plus 6 pi over 3, and we're getting, then we're taking pi over 3 plus 12 pi over 3. We're doubling that. Okay, well, what answers is that going to give us? That's going to give us, first we have pi over 3, then pi over 3 plus 6 pi over 3 is 7 pi over 3. Pi over 3 plus 12 pi over 3. Notice that 12 pi over 3 is the same thing as 4 pi. So it's like we put a 2 in for the k and the constant in our cyclical answer. Okay, so pi over 3 plus 12 pi over 3 gives us, excuse me, 13 pi over 3. That's my first three. Now let's look at the 5 pi over 3. So this one, my answers are 5 pi over 3, and then I've got 5 pi over 3 plus 6 pi over 3, and then I've got 5 pi over 3 plus, again, 12 pi over 3. So again, this is 2 pi, this is 4 pi. Okay, so it's how many times around the circle. So that's going to give me my next three choices here. So then I've got 5 pi over 3. I've got 5 pi over 3 plus 6 pi over 3 is 11 pi over 3. And then 5 pi over 3 plus 12 pi over 3 is 17 pi over 3. These would be my 6 specific solutions. Now, it doesn't say anything about them needing to be in order. If you want them in order, like the way they go around the circle, obviously you can reorder those. You'd have pi over 3, then 5 pi over 3, then 7 pi over 3, then 11 pi over 3, then 13 pi over 3, then 17 pi over 3. You can put them in order if you want. I don't think the book makes you do that. And once again, we have some dead spots here. Let me see if I can get filled in. Okay. So I hope this makes sense. So the first answer block, you have to give very generic, it's the 2 pi k for each of your 2 answers. And then your next one where they ask 6 specific solutions, you are taking each answer and adding 2 pi to it. Taking that answer, add another 2 pi, and so on and so forth. Okay, that's what they're looking for. Okay, number 6, same type of deal. Solve the given equation, and then they want 6 specific solutions. So they want the generic solution, then they want 6 specific ones. So mine is sine theta equals negative root 3 over 2. Okay, now we're talking sine. So first thing that I want to point out is sine is negative in quadrant 3 and quadrant 4. Okay, that gives us a negative sign because remember, sine is your y-axis. So below the x-axis, sine is negative. Okay, so if you look on your unit circle, again, remember sine is your y, so you get a negative root 3 over 2 when you get 4 pi over 3 in the third quadrant, and in the fourth quadrant, it is 5 pi over 3. So remember, theta is the arc sine of negative root 3 over 2, which again gives us 2 answers. This is quadrant 3, this is quadrant 4. Quadrant 3's answer, I'll put it in blue, make it maybe a little easier to see, is again the 4 pi over 3 plus 2 pi k. You have to give that generic answer that's cyclical. Okay, in quadrant 4, that answer is 5 pi over 3 plus 2 pi k. So those are the 2 answers on your first block. Okay, those are the 2 answers on your first block. You just separate them by a comma. Now, 6 specific solutions. So list 6 specific solutions. Again, I'm going to take each one of these, the 4 pi over 3 and 5 pi over 3, and add 2 pi. Again, I want to point out here that 2 pi equals 6 pi over 3, and 4 pi equals 12 pi over 3. Okay, so our specific solutions are going to be 4 pi over 3, and then we're going to have 4 pi over 3 plus 6 pi over 3. And then we're going to have 4 pi over 3 plus 12 pi over 3. And then this gives us 3 from the quadrant 3 answer. Now let's do 3 from the quadrant 4 answer. Then we're going to have 5 pi over 3. Then we're going to have 5 pi over 3 plus 2 pi, which is 6 pi over 3. And then we're going to have 5 pi over 3 plus 4 pi, which is 12 pi, 12 pi over 3. So we need to actually solve some of these here. So 4 pi over 3, this is going to give me 10 pi over 3. The next one is going to give me 16 pi over 3. Let me scroll down to get rid of my dead spots here on the board. The next one, again, is just 5 pi over 3. Then 5 pi over 3 plus 6 pi over 3 is 11 pi over 3. And then 5 pi over 3 plus 12 pi over 3 is 17 pi over 3. So this would be my 6 specific solutions. And again, I don't think they have to be in like numerical order. If they do, you can rearrange them. 4 pi and then the 5 pi, then the 10 and 11, then the 16 and 17. You can rearrange them if you need to, but I don't think you do. Okay, hope that made sense. All right. So first we solve it, take the arc sign, figure out what quadrant it's in, figure out our answer, give our generic one, then list the specific ones. Okay, next problem. Again, kind of the same deal, only we don't have to list specific. It says find all solutions of the given equation. Enter your answer as a comma-separated list. Let k be any integer. Round terms to 2 decimal places where appropriate. So I have root 2 cosine theta minus 1 equals 0. Now, we need to solve for cosine theta. So everything else needs to be moved off. It's almost as if I had root 2 times x minus 1 equals 0 and we were solving for x. Okay, so first step is to just move the 1 over. Okay, then I've got to divide by the root 2. I'm just trying to solve for cosine. Now, 1 over root 2 we know is root 2 over 2. Again, that is positive. Okay, so we've got theta equals the inverse cosine of root 2 over 2. And again, cosine is positive. Once again, I feel like a broken record in the first and fourth quadrant. Okay, so we're going to have 2 different answers. We're going to have quadrant 1 and we're going to have quadrant 4. Now again, if we draw our unit circle here, okay, this is going to be my pi over 4. Okay, this is like my negative pi over 4, which is 2 pi minus pi over 4, which 2 pi is 8 pi, okay, over 4. So 8 pi over 4 minus 1 pi over 4 is 7 pi over 4. And again, got some dead spots here. Okay, and if you look at your unit circles, same thing. Pi over 4, 7 pi over 4. Now, so our 2 answers then, this is going to give me pi over 4 plus 2 pi k. That's one of my answers. And then in quadrant 4 again, I had 7 pi over 4 plus 2 pi k. Okay? And again, both of those answers would need to be listed. Okay, next one, number 8. Find all solutions of the given equation. So now I have 4 sine squared theta minus 1 equals 0. 4 sine squared theta minus 1 equals 0. Now, got to solve for just sine theta. So this is 4 sine squared theta equals 1. Then divide off the 4. So sine squared theta equals 1/4. Well, I just need sine. I don't need sine squared. Now, and I can't really substitute the sine squared with any formula because I'm still going to end up with a square of some kind. So how do I get rid of a perfect square? I square root. But when I do that, what do I have to be careful of? I have to be careful of plus and minus. Anytime you use the square root procedure to solve a quadratic, this is what this is, even though it's a trig function, it's quadratic. You've got to do the plus or minus. So this gives me sine theta equals plus or minus 1/2. I hope you all will agree that the square root of 1/4 is 1/2. Square root of 1 is 1, square root of 4 is 2. But again, I got the plus minus. Now, since it's plus minus, this is going to give us answers in all 4 quadrants. Now, we have to be careful with that because what we actually can do then is just find the answers in the first and second quadrant, and instead of adding 2 pi k, add just pi k, so that it's going to give you the same thing every 180 degrees. Okay, so that's what we're going to do. We are going to find answers in first 2 quadrants and add pi k instead of 2 pi k. Okay, if I do just pi k instead of 2 pi k, then it gives it to me every 180 degrees. So the first quadrant answer plus pi k would give me the same one in the third quadrant. The second quadrant answer plus pi k would give me the same answer in the fourth quadrant, and so on. So it'll save me from finding 4 answers and adding 2 pi k to all of them. I can just find 2 answers and add pi k to them. I hope that makes sense. So where sine is 1/2 is pi over 6 we're just going to do first and second quadrant. So we have pi over 6 plus pi k for the reason I just wrote down there in purple. Okay, so pi over 6 plus pi k will give me pi over 6 and then 7 pi over 6 and then 13 pi over 6 again. So this is pi over 6, 7 pi over 6, 13 pi over 6, so on. Remember that we're just adding 6 pi to the top each time. Okay. And then in quadrant 2, the answer is 5 pi over 6 plus pi k. That's my other answer. And again, that would give me cyclically 5 pi over 6, 11 pi over 6, 17 pi over 6, so on and so forth. Okay. So these would give me all 4 quadrants the answer. But again, they're cyclical, so it's just going to keep going. So this and this are my 2 answers. Okay, that's what you put in the blank. Okay, I am actually going to stop there since we're going on 30 some minutes, and I will do problems 9 through 20 in the second part.